In this example, we have a car traveling towards a stationary observer. The driver beeps the horn, and the horn has a true frequency of 355 Hertz. The velocity of the car is 21.0 meters per second towards the observer, and the speed of sound is given as 345 meters per second. And the question is, what's the frequency that the observer actually hears? Well, to figure out the frequency that the observer will hear, we have to take into account the Doppler effect. And the Doppler effect equation is given as the observed frequency equals the speed of sound plus or minus the speed of the observer divided by the speed of sound plus or minus the speed of the source, all times the true frequency of the sound. Now, the equation itself is not so bad. The problem is these plus-minus signs. In each case, we have to figure out whether to use a plus or a minus every time you see one of those plus-minus signs in the equation. Well, let's start with the one that's in the numerator, V sound plus or minus V observer. Do I use the plus sign or the minus sign here? Well, actually, it turns out it doesn't matter. The speed of the observer is 0. So whether you use the plus sign or the minus sign, the numerator of this fraction just turns into V sound. Alright, let's move to the other plus-minus sign, the one that's in the denominator of the fraction. It turns out this is harder because the speed of the source is not 0. So it really does matter whether we use the plus or the minus sign. So which do we use? Well, in order to figure this out, we have to think about the situation. Look at the drawing. The car is traveling towards the observer. As the car travels, it's emitting sound waves. Those sound waves get bunched up in front of the car because the car continually travels as it emits the sound waves, and they get spread out behind the car. So the observer is going to encounter these sound waves as they are bunched up. Well, if the sound waves are bunched up, that means their wavelength is smaller than they otherwise would be, which means their frequency is higher. So the observer is going to experience a higher frequency of sound waves. So what we have to do is figure out how to use this equation to make the observed frequency higher than the true frequency, because that's what the situation tells us will happen. So how do we use this equation to make the observed frequency higher? Well, if the observed frequency needs to be higher, then this fraction needs to be greater than 1. I increase the value of a fraction when I decrease its denominator. So I need to make this denominator decrease. The way I can do that is use a minus sign in the equation. If I use the plus sign, I would be adding V sound and V source. That would create a large number, and when a large number is in the denominator of a fraction, that makes the fraction small. However, by using the negative sign, I'm making the denominator smaller. That makes the fraction larger, and that allows the observed frequency to be greater than the true frequency, which is what we need. Well, now that we've figured out that we need to use a minus sign in the denominator of the equation, everything else is pretty simple. The observed frequency is simply the speed of sound, 345 meters per second, divided by the speed of sound again, 345 meters per second, minus the speed of the source, 21.0 meters per second. All of that times the true frequency, 355 Hertz. When we work out the numbers here, we find out the observed frequency is 378 Hertz. That's higher than the true frequency, which is what the situation demands, so we know we've used the equation properly. Now let's step back and look at this problem. Once we decided whether to use the plus or the minus sign in each part of the equation, the problem itself became rather simple. So the difficult part is figuring out whether to use the plus sign or the minus sign in the equation. However, if you understand the concept of the Doppler effect, that really shouldn't be a problem. You should be able to look at the situation and decide, is the observed frequency higher or lower than the true frequency? That should help you decide whether or not to use a plus or a minus in each part of the equation.